Hey Drew class, let's look at this problem from the 7-8 homework set dealing with phase shifts. And so we got a tangent function this time, and we've got a subtraction that's going on the inside. So we're going to have a shift of the graph. All right, so first of all, tangent, when we're talking about amplitude, we're talking about how high does the graph get off the midline. And, we have a peak, a valley, and then these midline intercepts. This is amplitude, like to the highest to the lowest. The tangent function, though, it has asymptotes, and it does have an intercept of what's typically the x-axis. And then, if it's shifted like this one is, it's not necessarily going to touch the x-axis. This one will. But there is no maximum departure from this midline or this x-intercept. So there is no amplitude, going by the definition of what amplitude is for sine and cosine. So if you come down here, that would be the amplitude doesn't exist because we're talking about tangent, cotangent. All right, period. Typically, for the period of the tangent and cotangent functions is typically pi, and then whatever number is in front of x, we divide that period of pi by that. So our period here is going to be pi divided by 2. The fraction, pi in the numerator, 2 in the denominator. All right, the phase shift. So the way I could basically come up with phase shift is I just take this 2x minus pi that's inside the tangent function or inside any of these functions, and I set that equal to the origin, 0, where we typically would start. And you can see that if I move that pi over, I'll get a positive pi, and I would have 2x equals pi. And then dividing both sides by 2, I get x is equal to pi over 2. All right, that's positive, so that means pi over 2 units to the right. Pi over 2 again. All right, and now we have to come up with what the correct graph will look like. So again, here's how I do this. This is my method. This is not necessarily what you'll see if you click on View an Example. But I think when I think of the tangent function, there's the x-axis, there's the y-axis. This is negative pi over 2. There's positive pi over 2. I always think of these two asymptotes. That's where they occur, negative pi over 2, positive pi over 2. Now, I'm going to find, because of the phase shift, where do these two asymptotes occur? So I take this expression, 2x minus pi is equal to negative pi over 2. I want to find out where is this going to occur? Where is this new value going to be? So I'm going to have to isolate x. I'm going to have to add pi to both sides. So I would lose the pi. I have 2x on this side, and on this side, minus pi over 2 plus pi is positive pi over 2. All right, I can again do that with my calculator with ignoring the pi's. Negative instead of pi over 2, just do a half. Plus, instead of adding pi, I'm just adding 1. And then back into a fraction, and then stick a pi back there. So again, I always do the math without pi. So this would, instead of a negative pi over 2, I think of it as negative 1 over 2. Plus pi plus 1 pi. And that gives me positive 1. Stick the pi back and I have pi over 2. However it helps you do that math. And then I'm going to divide both sides by 2. And I get x is equal to positive pi over 4. So that is my left vertical asymptote. That was at negative pi over 2. All right, now my other one was at positive pi over 2. So I'm going to do the same thing. 2x minus pi and now equals positive pi over 2. Adding pi over just like I did before, I get 2x, these cancel. I get 2x equals pi over 2 plus pi is 3 pi over 2. Again with the calculator, pi over 2, 1 over 2, plus pi plus 1 into a fraction, 3 over 2. So stick the pi back in there, 3 pi over 2. Divide both sides by 2, I get x is equal to 3 pi over 4. Right, that is my right vertical asymptote. Right, the vertical asymptotes for tangent are always separated by the period. There's always a period between vertical asymptotes. And if you subtracted 3 pi over 4 minus pi over 4, you would get 2 pi over 4, or pi over 2, which is our period here. So I need my left vertical asymptote to be pi over 4, my right one to be 3 pi over 4. So there's a pi over 4 for that vertical asymptote. There's 3 pi over 4. So that's a possibility, that's a possibility. There's a 0, there's a pi over 2, there's a pi. For those are out. So we've narrowed it down to these two. All right, and the original tangent function. halfway between the vertical asymptotes is the midline intercept. All right. Now, if we shifted this vertically, it would be off of the x-axis, but we're not shifting this vertically, meaning we're not subtracting or adding anything after multiplying by the 3. So this is going to intercept at the x-axis right in the middle there, which again, the average of these two would be 2 pi over 4 or pi over 2. All right, so we need to intercept there, and we are again in both of these. It's just all going to come down to, do we fall or do we rise? And that's where we're going to see that the choice here is B. For the tangent function, if we don't have negatives, the first quarter period point is going to be down. It was at -1. This was at +1. Because of the 3 here, this is going to be down at -3. And this is going to be up at +3. All right, and the graph does something similar to this. It approaches those asymptotes. It's pretty poorly drawn. Going to go through the intercept. There we go, something like that. All right, and then it's going to, again, copy paste. It's going to keep doing that between every asymptote. So it is rising because that's a positive. So that means that B is our choice. All right, so when you're graphing this, obviously a calculator will help. I mean, I could just do zoom trig and get that tangent function. All right, this again, we would want to make sure we have somewhat the window that they're giving me here. So the x-axis is going between 0 and pi over 4, 5 pi over 4. I'm going to do 0. So I do see the y-axis. And 5 pi over 4. And you can see the scale there looks like to be pi over 2, those asymptotes. I'm going to do pi over 4. So I'm seeing the tick marks on the inside too. And then my min and max for y, -6 and 6. And again, when I look at it like that, it's obvious that it's B for the fact that it's just the fact that it's rising. And I see an asymptote coming off of the y-axis. So I know it can't be any of these that are falling, A or C, that are falling downhill left or right. So my calculator can basically get me that part, but you're going to need to be able to show that you can do it by hand, that you can shift these graphs around. So do make sure that you can go through the process of shifting sine, cosine, tangent, secant, cosecant, all of them. But especially with these phase shifts, definitely make sure you can do it with sine, cosine, and tangent.